Stizor, let's talk about certainty. You didn't really address the other questions there, but let's just talk about certainty. I understand the physics and math involved. I mentioned on math that there's certainties within math, but where the uncertainty of math, insofar as it pertains to material reality, where that uncertainty lies is in the axioms. Right? There's alternate math. You can build a certainty called a tautology, right? You can build a tautology, but even it will have uh, problems with certainty at the edge where you want to apply it to real life, the applied math that you've been talking about. You say that certainty is just an acknowledgement of what appears. Well, I mentioned relative certainty, and that's what relative certainty is. But certainty, as it's traditionally talked about, is unqualified. It's absolute certainty. For example, if you're traveling at this speed, it takes, you know, this long to get from this to get this distance. That was more or less an example you used. But we know with general relativity that's not true, that how long it takes to get somewhere depends on the frame of reference that you measure it within, right? Right? Yes. Okay. Furthermore, use a lot of examples of certainty that are naming things. Well, these are attempts at tautologies, but you say, uh, I know this highlighter is a highlighter. You say, that's what it is. It's a highlighter. That's certain. It's a highlighter. No, it's a bunch of molecules. Oh, but that's what a highlighter is a bunch of molecules. Well, if you're going to say that this is whatever name I give to whatever it is that I don't know all the details of, then you're trying to create a tautology. But the problem is that if you try to have an idea about what this thing is materially, then you will face the uncertainty again. Now, there's relative certainty in the real world. Relative certainty. One thing can be more likely, more certain, have more facts going for it than another thing. That's how material reality works. Now, in mathematics, you've created a tautological system so that you can ignore the real world. But as Einstein said, as soon as you apply it back to the real world, it won't be 100% accurate. You can take a Cartesian coordinate system, all of the beautiful geometric statements within it. They're certain within the domain. That's what makes it relative. If it was absolutely certain, it'd be true everywhere. But it only counts as certain within this domain where you accept the axioms of Cartesian space. If you have some other sort of space, which we do right now, we define space as in terms of these Hamiltonians, then you lose the certainty that you would like to have if you're talking about something that is just true in general. You know, if it's a certainty that this is a highlighter, why are there people speaking other languages calling it something else? Oh, that's just a different word for the same thing. Oh, but that's a word for the idea. And it's the idea of a highlighter that in your brain that does not match with certainty what this really is. Okay, the model of a highlighter in someone's brain is, it's something you use to highlight text. That doesn't match that this is actually just a bunch of chemicals and that a different highlighter is not only a different bunch of atoms, but, could be different ink and in truly different types of chemistry. Okay, so that's what I was talking about. And you might also want to understand who I was responding to is a guy who is an objectivist. Ayn Rand. You ever heard of Ayn Rand? Now, they like to say that they believe in an objective scientific reality. But in fact, they promote their own interpretation of that onto the world. Like they don't believe in relativity and quantum mechanics. They like to debunk relativity and quantum mechanics because they're not certain. They're not determinable enough in actuality. Now, I get the impression that you do know what I'm talking about, that you know that a math of some sort, that some mathematical system, in fact relies on axioms, and that those axioms are not at all certain, you know. Now the thing about relative certainty is you can know enough, right? You can totally know enough in order to do what you need to do in life. Okay. But I don't really know enough to say that it's absolutely certain that this is a highlighter. That's the whole point of life could be some sort of an illusion, right? It could be some sort of an illusion. So maybe this is nothing like what I think it is. It has the function. I can know that it can reliably be used for a function, but one day I might pull it out, try to use it for that function, and it won't work. The ink is gone. Same thing with the coin. The certainty is the idea if I flip a coin, I am certain it'll come up heads and tails. But as you point out, it has the edge. And they've tested this, and actually coins do land on their edges, especially on uneven surfaces. I've known people that had that happen when it was on an uneven surface and the coin managed to land right in a little divot that sort of helped it do this. But even without that, on a flat surface, if the side of the coin is flat, then it can land that way. But you said there's three sides. Maybe we're certain that there's three sides. But is this side of the coin, I don't know if I have a coin. Probably not. I don't carry a lot of coins. Is one side of that edge the same as the other side? So that's all one side. So a circle has one side, for example. So if there's a lake shaped like a circle, I'm on the same side as the guy that's across the lake. See, a side is what we name a feature, right? We name this aspect that's important to us in our interpretation of the object a side. In reality, the coin doesn't have sides. It's got a bunch of individual discrete atoms. There's gaps between them. If you get down small enough, you'll see that the concept of side doesn't really apply to the shape of that thing when you get into detail. And ultimately, this leads us to a final assessment of these absolutes. Because people love to find an absolute as well. Hey, it exists. That's absolute. But if you say something exists, what you're doing is you're avoiding every single detail about it except for the one tiniest detail possible. Now, I consider that a funny kind of certainty where you ignore every detail and in that statement and say that it's certain that it exists. Because while it could be true, you then have to tell me what is the definition of exist. And that is where you'll get back into reality. Oh, well, it's atoms. No, I'm sorry, they're all material. The atoms aren't little BBs and so on. Any physical theory that you're going to present saying how it actually exists, what existence means, is going to bring in the uncertainty again. Now, humans have a lot of ways of ignoring uncertainty. Why? Because making approximations is fundamental for limited mortal material beings. You have to be able to make approximations because your mind is limited. You don't have time to calculate every detail, even if it was possible to know every detail. I don't believe it's possible to know every detail. But even for a very, just an entirely unlimited mind, as much as you can imagine that. But for us, with our limited mind, pretty sure it's not possible to know every detail. So we have to make approximations. But what I object to is when we make an approximation and say that the remainder is certain. No, because we don't know how the things we've ignored, affect the part that the approximation that we made. So why emphasize that? So that's my point. Cheers. No, it's...